Alright, here we go. Lesson 4.4, trigonometric functions of any angle. We're going to evaluate trig functions of any angle, and we'll see how to do that today. We'll also work on finding a reference angle, and then eventually, not in this video, but eventually in class, we'll use that to find trig functions of any angle. So we'll build on what we get here. This is most of 4.4, but not quite all of it, and we'll finish it in class on Wednesday. Alright. Here's just a generic summary of the 6 trig functions and how they relate to a angle theta. If you notice here, the one thing we don't have is this r value, which we've been using before for the unit circle, was always 1. In this case it is not, and so they define by sine by y over r, which we were thinking of sine in terms of y before. Likewise, cosine is x over r. Remember, before we were dividing by 1, so we just ignored this value. We ignored the r value. In this case, we have to take it into consideration. And from there, we can build all the other ones. Tangent is still sine over cosine. Cotangent is still the reciprocal of tangent, and so on. So we still have all those relationships. Alright, using that last picture, we have let -3, 4 be a point on the terminal side of the angle theta. Find the sine, cosine, and tangent. Well, we have this as my point, so x is -3 and y is equal to 4. We can use these to find r, which is really just the distance or the hypotenuse, so it's Pythagorean theorem or distance formula, however you want to look at it. But it's the square root of 3 squared plus 4 squared, and we know that it's a 3, 4, 5 triangle, so r is 5. If I want to find sine, we know sine of theta is y value, but we have y over r in this case, so it's really equal to y, which is 4, over r, which is 5. And if we notice this point -3, 4 is in the second quadrant, and it makes sense that in the second quadrant this should come out as positive. If we have cosine theta, that would be x over r, which is, in this case, -3/5. And again, it makes sense for that to be negative because we're in the second quadrant. And then finally, tangent is y over x, or you can think of it as sine over cosine, y over x. So in this case, y is 4 and x is -3. And so these answers here give me my 3 trigonometric functions, and from those you could easily find the remaining 3. Alright, an example problem, same situation. You have x, you have y, and you'll use those to find all of the other values of the trig functions. Alright, moving on. Alright, we're giving something similar. I have tangent of theta equals -5/4. So that means from here, remember my definition of tan theta is equal to y over x. Alright, so I know y is 5 and x is 4. What I don't know is which one of these are negative, but they give me this extra information, right? I know from the fact that I have -5/4, one of those has to be negative. The other has to be positive. Cosine of theta, which is x, is greater than 0. That means that positive, so that leaves -5/4. So I'm not going to work from there. Sine. To find sine, I'm going to have to know r. So remember, r is the square root of v squared, the distance formula, 5 squared plus 4 squared. So that's root 41, and that doesn't simplify any, so I can work from there. If I want to find sine of theta, that is y over r, which would be -5 over root 41. If we get rid of the radical on the bottom, that becomes -5 root 41 all over 41. And secant theta, remember, secant is the reciprocal of cosine, so we have, normally we would have adjacent or x over r. In this case, we're going to have r over x. So r is negative 5, or excuse me, r is root 41 divided by x, which is 4. So root 41 over 4. So we have both of our answers there. Alright, moving on. Another example problem, they do the same thing. They give you a constraint to help you figure out which one of these values is positive or negative, or both could be negative in the case of number 24. Alright, reference angles. So no matter when you draw a angle, there's always a terminal side that forms a value with the x-axis where the angle is acute, where the angle is less than 90, and we use that as our reference angle. And so if you look at these pictures, this is my angle theta here that they map out for us. Well, my reference angle, it's always between my terminal side and the x-axis. So in this case, it would be down here. If I look at this one, it's mapped out here. So my terminal side, it needs to be less than 90, or my smallest side here, that's between the x-axis. So that's there, and then same thing here. This will be my reference angle. So if I'm given 300 degrees, 300 would be all the way around to here. This is 270, so then I've got to go 30 degrees more. So this part is 30, which means for letter A, my reference angle, again, I have to go between the x-axis, and we label the reference angle as theta prime, so theta prime in this case would be 60 degrees here. Alright, if we look at letter B, this is in terms of radians. Alright, so we have 2.3. We have to figure out where that is on our axis. Alright, so one of the things you have to remember is about how many radians each of these axes are. So this is pi radians, or 3.14, and this would be pi halves radians, which is about 1.7. So I know I'm going to be over in here somewhere. Alright, so this will be my angle theta. My reference angle is going to be in here. It's theta prime, and to figure out what that is, we know this is theta, or excuse me, we know this is pi, 3.14. So we would do 3.14 minus 2.3, and from there you can figure out what your reference angle is. And then letter C, you have theta is negative 135. Negative, we're going in this direction clockwise. Negative 90 gets me to here. To get to negative 135, that's 45 degrees past, which means I have 45 degrees here. So my reference angle is 45 degrees. Alright, theta prime. And an example of doing exactly the same thing. Notice that A and C are degrees, and then B asks you to do radians.